Hi students, I am Dr. Prabhu, Department of Civil Engineering, Communal College of Engineering and Technology. So in the laboratory series, you can see the water supply and wastewater engineering laboratory experiment. We are seeing water supply and wastewater laboratory experiments, and today we are going to see determination of COD. So all you know that the COD is a chemical oxygen demand test, measured how much dissolved oxygen is consumed when organic matter and inorganic components are oxidized in the water. So this is known as COD, and the application of COD is to identify the wastewater quality and the pollution sources, identify the severity of wastewater, and also to cross the connect of sewers and effluent pollutions. So these are all the things which is used based on this test we are going to identify, and this is some of the applications of this COD. So let us see in the laboratory how does the COD can be measured in practical. The introduction we have seen about what is COD and what is the purpose of this experiment in doing this chemical oxygen demand in the water. Today we are going to see what is the equipment and the reagents, the glasswares which is used for this COD. So just I am having two virals to use in this heating mantle machine. Okay, so you can have a setup for this viral like this, and here I have collected a sample of 3 ml. One is a wastewater sample and one is a blank sample I have collected here. And next, sulfuric acid I have with us, and potassium dichromate, and for the burette solution I have already filled with the burette of FAS, ferrous ammonium sulfate of 0.025 N normality, and we have boroxide as an indicator. So first you can add a blank sample of 3 ml. The blank sample may be a distilled water, and next I am having a wastewater sample of 3 ml. So here I am adding 1.5 ml of potassium dichromate, and 1.5 ml of sulfuric acid, so 1.5 ml of sulfuric acid and 1.5 ml of potassium dichromate. And the same for the sample, 1.5 ml of potassium dichromate can be added, and around 1 to 1.5 ml of sulfuric acid can be added to both the samples. So one is blank sample with the 3 ml of sample water, and there is blank sample water, and 1.5 ml of potassium dichromate, and 1 ml of or 1 or 1.5 ml of sulfuric acid. Okay, and the same way I am adding this to for the wastewater, so wastewater also. And next, in another case, you can add a little bit of mercuric sulfate as a pinch here for both the samples. So let me add sulfuric acid, sulfuric acid to a pinch, So now this is the pinch for both the samples. And just you can mark here the samples in terms of wastewater sample and also a blank sample. So blank sample I am keeping in the heater first, the wastewater sample I am keeping next to this. So and let us close here and you can watch this equipment. So make start of this equipment after the power. Just keep the temperature. You can make the temperature to 100, 120 and 150. I am keeping it as 120, 150 as my temperature, and time we can mark here. So it is nearly 1 hour 20 minutes I have given. If you want, you can change the time to 60 and 30. So let me have 120 minutes as my time, and let's make the instrument to start and heat. So once the heating button is on, automatically the 150 degrees get off blink, so that it is getting off digestion process. Okay. So once it get off digestion after 1 hour, you can collect the sample and reduce the heat and make cooling the sample, and we have to titrate with FAS, that is ferrous ammonium sulfate, and adding the monoxide as an indicator, and we will see after 1 hour the digestion of this sample. So after making cooling of this viral, so I have transferred my sample to an volumetric flask. Okay. So once it has been traveled to the volumetric flask, the cooled sample. So let us add a pinch of ferroin indicator. So let us have a little bit pinch, because once the color has got much higher, we cannot see the change point of green. The green is our change point actually. So let me have a little pinch of monoxide. I am adding into it. Is enough. And let us shake. Okay. And now, after releasing the air bubbles from this burette, okay, let me measure the initial reading, and little gently I am making it to titrate to it. So until the light green color, a light grayish green is the change point of this experiment. Until it, you can make a titration of it. Yes. Okay. So it has been changed to some dark green. Okay. We will stop it here and measure the reading. And the final reading of this, after changing into the light greenish or grayish color. So the initial and final reading has been noted from the burette. So as for the last experiment, like the last experiments. Hence the permissible limit for COD, there should not be any COD in drinking water purpose. Okay, so if you are testing this for drinking water purpose, so you are studying studying in the theory part, water supply and wastewater engineering. So in the public water supply, the COD should be nil, and there should not be any COD here. Okay, so this is the permissible limit as per 10,500 code. Okay, so thanks for watching this video, and thank you all.